Ok, we're live. Hola a todos. Tenemos como un delay como de 30 segundos aproximadamente. El día de hoy estamos con Karl Singline. Vamos a platicar un poquito de la manufactura digital y su aplicación directamente con robots. Vamos a platicar un poquito del proceso, vamos a conocer algo de Kuka PRC y vamos a hacer un micro tutorial donde vamos a explicar muy rápido, muy concretamente, cómo funciona KUKA PRC, de qué se trata, cómo se hace se pone la escena inicial y bueno, vamos empezando. Vamos a ver, Carl, we're live. Do you want to say hello? Y solo para checar si nos escuchan. Saludos a todos. Por ahí veo, hola a todos, veo ahí a Astrid, Luis, Makers, Marce, todos, buenos días, Sebastián, Rocco, Víctor, Ronan, solamente para confirmar si nos escuchan por allá. Y como les digo, tenemos un delay, entonces tal vez si nos escuchan y no me han escuchado. Bueno, vamos arrancando. Hey Carl, do you want to say hello to everyone or you already did?
Hello, can you hear me?
Yeah, I can hear you.
Yep.
Make sure somebody... Let me make sure they're listening to us. Let me make sure it's okay. Ok, gracias Ronan, ya nos confirmaron que sí nos escuchan y vamos a arrancar. Bueno, manufactura digital con KUKA PRC. Entonces, iniciamos. KUKA PRC, para platicarles un poquito de la historia, es un programa desarrollado por Johannes Braumann en Austria, Linz. Y él hace KUKA PRC con el objetivo de hacer los robots industriales accesibles a la industria creativa. Entonces, Johannes Plaumann, Karl trabaja ahí con él en la universidad, desarrollando KUKA PRC y haciendo proyectos con él. Ahorita nos va a platicar un poquito más de esto, pero realmente el objetivo detrás de KUKA PRC es cómo podemos hacer que los robots no hagan una cosa 1000 veces, sino cómo hacemos 1000 cosas una vez. ¿Cómo podemos llegar a esta personalización en masa? ¿Cómo podemos hacer que los robots fabriquen no una cosa repetida n cantidad de veces, sino que cada una de las cosas que vamos a hacer con el robot pueda ser personalizable, pueda ser diferente? Igual les comento a todos los que nos están escuchando, pueden ir preguntando, ahorita vamos viendo cómo va avanzando todo. Si tienen alguna duda, al final las vamos a tratar de responder la mayoría de las preguntas y si es pertinente, vamos a interrumpir para contestarla en el momento. Bueno, ¿qué ventajas nos da KUKA PRC? Lo primero es que es accesible y tiene por medio de un sistema de programación visual paramétrico. No sé cuántos de ustedes estén familiarizados con Grasshopper en Rhino 3D. Grasshopper realmente es este lenguaje de programación que nos permite programar en objetos 3D desde Rhino. Aquí podemos ver todas las funciones que tenemos en Grasshopper, pero nos vamos a enfocar en las de KUKA PRC. Entonces usamos un lenguaje de programación visual por nodos que nos permite programar el robot. Realmente lo que estamos haciendo, bueno, ahorita para no adelantarme, vamos por partes, disculpa, pero vamos a seguir. Otra de las ventajas de KUKA PRC es que podemos de manera inmediata visualizar las simulaciones que tenemos con el robot. Esto quiere decir que conforme vamos programando el robot, podemos ir viendo en tiempo real todo todos los cambios que vamos haciendo. Entonces, no nos gusta algo, lo movemos, visualizamos en el robot. Vamos a ver un poquito de esto. Tenemos un slider aquí que nos permite, este es nuestro robot, ahorita les enseño cómo está montado, pero bueno, nos permite con KUKA PRC podemos ver los movimientos del robot. Aquí si hubiera algún tipo de colisión, algún tipo de singularidad, nos podría dar alguna alerta. El robot se pinta de rojo y nos dice cuidado que ahí no, ahí puede chocar. Ahorita tratamos de hacer que choque para que vean cómo se ve en el simulador. Y algo muy interesante de KUKA PRC es que se integra con toda la comunidad de Rhino 3D y con todos los tools y add-ons que ya existen. Súper interesante, por ejemplo, está OWL, que nos permite hacer Machine Learning con KUKA PRC. Entonces, integrar Machine Learning con el robot se empieza a hacer bastante rápido, se facilita bastante. Entonces, vale la pena darle una revisada a los add-ons que están aquí. La mayoría pueden hablar con KUKA PRC de tal manera que todas estas aplicaciones se pueden conectar con KUKA PRC. Y finalmente, KUKA PRC es extendible y customizable. Podemos ponerle N cantidad de, no recuerdo ahorita el número, pero de sensores externos. Podemos ponerle 2 o 3 rieles, donde podemos tener al robot trabajando dentro de un edificio, moviéndose por todos lados. O por ahí nos comentan que el audio no se escucha bien. Voy a acercar más el micrófono. Ahí si por ahí alguien ve algún problema, les pido que por favor me comenten. Gracias. Thank you, Sydney Dubinion, for letting us know. I'm not sure what's wrong with the audio. We're trying to figure it out. Maybe it's the microphone. Entonces podemos agregar diferentes ejes al. Y bueno, el día de hoy nos vamos a enfocar principalmente en la aplicación de manufactura digital, en maquinado, corte e impresión 3D. Karl nos va a dar algunos ejemplos de la industria creativa y cómo funciona. ¿Cuál es un poquito el proceso? Normalmente una persona que ha trabajado con impresoras 3D, con CAM, con CNC, con esto, más o menos se identifica con este diagrama en el que tenemos una idea, diseñamos un software CAD, a veces el mismo software CAD puede tener el CAM para procesarlo en código G, que después la máquina lo convierte al objeto, y ahorita lo único que vamos a agregar es que tenemos igual la idea, usamos un software CAD CAM, en este caso puede ser el mismo Rhino, lo conectamos con lo convertimos este código G que generamos con Rhino CAM, con Fusion 360, Cura para imprimir en 3D, con Simplify, etcétera. Y por medio de KUKA PRC podemos convertir este código G al lenguaje de robot, que nos permite de la misma manera con los actores del robot convertirlo a un objeto. Se oye, pero se entrecorta. Se sigue yendo entrecortado. Bueno, no sé qué problema puede estar aquí con el audio. Gracias, Sergio. Si hay algo que no se entiende, me pueden decir y lo repito. Como les comento, tenemos un delay como de unos segundos, ¿verdad? Okay. So, Karl, they're telling me there's audio is breaking up. Microphone.
Okay.
Can you?
I'm listening on Discord, not on YouTube.
Yeah. Let me try to figure this out with it. Ok. A ver, ya le traté de arreglar aquí. Vamos a ver si funciona un poco mejor. Ok. A ver. Gracias. A ver, ya lo separé un poquito. A ver si funciona mejor. Y bueno, vamos a seguir. Bueno, en KUKA PRC tenemos como les comentaba, tenemos varios nodos. Aquí arriba tenemos los nodos que nos permiten, por ejemplo, hacer un movimiento lineal. Tenemos los robots, tienen varios robots de KUKA, robots de cajón que tiene KUKA, creo que se pueden agregar más. Entonces, podemos aquí escoger el tipo de robot con el que estamos trabajando. En este caso, estamos trabajando con un KR6 R900. Acá tenemos para configurar nuestro tool, podemos crear nuestro propio tool, podemos ponerle una sierra, podemos ponerle cualquier tipo de router, podemos ponerle un extrusor de impresora 3D. Tenemos toolpath que utilities que nos van a permitir aquí hacer todo lo referente a agregar, quitar, hacer traslados intermedios, código de inicio, código para finalizar, agregar el código G, agregar código G de ¿cómo se llama? De Fusion 360. Y bueno, tenemos acá otros bloques que nos facilitan la vida, por ejemplo, para esperar en el digital input, esperar la respuesta de algún actuador que tenemos para que nos diga que ya podemos iniciar con un trabajo. Y finalmente podemos tener en tiempo real, podemos tener comunicación vía MX Automation. Es un programa de KUKA que nos permite comunicarnos en tiempo real con sus robots. Y Sunrise para el robot KUKA Iwa, el nuevo. Esto es más o menos como se ve normalmente un algoritmo para trabajar con KUKA PRC. Este es el bloque más importante, es el core. Y bueno, el primer parámetro que está esperando es un valor flotante, que es realmente el estado de la simulación de 0 a 1. Entonces, podemos dividirlo, por ejemplo, en 10 y podemos tener 10 pasos del simulador. Entonces, moviendo este simulador, podemos poner el estado de la simulación, en qué porcentaje está de la simulación. Posteriormente están los comandos. Aquí podemos previsualizarlos con un panel. ¿Dónde están los paneles? Panel. Y aquí lo que estamos haciendo, lo podemos visualizar un poquito. Aquí viene una liga al archivo de código G. El código G es G1 con el X, Y, Z opción. Y aquí lo que está haciendo es convirtiendo este código G al movimiento lineal del robot KUKA. Esto lo conectamos aquí a los comandos. Acá abajo ponemos el tool, que lo que está calculando es la orientación y rotación del tool para poderlo calcular en el robot. De tal manera en que, si se fijan por acá, podemos alcanzar a apreciar un poquito a ver, lo voy a poner al final para que se vea. Si se fijan, aquí se puede ver la punta del tool, la orientación y la rotación. Entonces eso lo configuramos en el Custom Tool. Hay algunos tools que ya vienen predefinidos por acá. Podemos utilizarlos. Por ejemplo, vamos a usar un router, generic spindle, lo conectamos al tool y podemos visualizarlo con el spindle. Entonces igual podemos aquí visualizar lo que estamos. Aquí está mi grasshopper. Y con el slider podemos visualizar esto. Entonces podemos hacer nuestros propios tools aquí en KUKA PRC. Y bueno, el robot, aquí simplemente estamos escogiendo qué tipo de robot estamos utilizando. Si lo cambio, por ejemplo, buscar uno grande, Quantec, KR90, KR120, a ver, este de aquí, que es más grande. Y lo conectamos acá, cambiamos el robot. Entonces, viendo es un robot mucho más grande y ya nos está generando aquí algunas colisiones y nos está diciendo que por ahí hay algún error que tenemos que revisar. Entonces se pinta de color rojo y en el mismo nodo nos dice que hay algo anda mal y podemos ver aquí los errores que tenemos. Y bueno, aquí en colisiones podemos poner cosas dentro de nuestra celda que también pueden estar colisionando con el robot y nos permite que la simulación nos dé tiempo real si hay algún problema. Y bueno, en general esto es lo más importante del KUKA PRC. Estos comandos pueden venir de una lista de puntos que tenemos en Grasshopper y después podemos convertirlos por medio de todas las aplicaciones que tenemos aquí en KUKA PRC. Podemos convertirlo a un path para el KUKA PRC. Por ahí Karl nos va a hablar un poquito más al respecto. Y ¿qué más tenemos? Este también es bastante importante. Es donde configuramos nuestro robot, nuestro programa, donde podemos tener una base. En este caso, la base, por ejemplo, aquí lo que hicimos fue agarramos un código G de una impresora de 40 por 40 centímetros. Este es el origen de la impresora. Y entonces aquí en la base yo puedo mover este origen de la impresora para mover el lugar en donde voy a imprimir. Por ejemplo, si lo puedo poner lo podría rotar, creo es el B. a 45. Entonces, esto creo que me lo rotaría lo correcto. Me rotaría la impresión 45 grados. El robot fue el que se rotó, la base la dejó igual. Pero si tenemos el robot montado, ya está calculando esa rotación de menos 45. Entonces, con esto podemos, dependiendo de la posición de nuestro robot, podríamos ubicarlo, por ejemplo, en una celda que esté en la parte de arriba, en uno de los lados. La base podría estar montado también en uno de los laterales. Entonces aquí es donde montamos eso. Aquí escogemos la base, qué base es la que estamos trabajando. Esto más que para aquí, para la simulación, nos sirve para el robot. Una vez que lo exportamos, la primera línea de código, si se fijan aquí ya nos creó un archivo de, nos va a mostrar, nos creó nuestro primer archivo ya de, voy a pasar para acá. Editor. Y aquí está. Entonces, esto ya es el código que nos generó Kuka PRC, lo hace en automático. Aquí ponemos el archivo donde queremos guardarlo. Y entonces, esta base que escogemos aquí nos la va a identificar. Base is 9, tool is 6, speed is 15%. Entonces, todo lo que estamos haciendo aquí es programar el código de inicio del Kuka PRC. Y bueno, y todos los settings que tenemos de nuestro tool, de la base, etcétera, etcétera. Estos son más parámetros, pero KUKA PRC lo hace fácil. Tenemos algunos parámetros avanzados para cambiar algunas cosas y tenemos el análisis de los movimientos que estamos haciendo. Y bueno, regresando a la presentación, ya vimos esto y bueno, ya vimos que podemos ver en tiempo real lo que estamos trabajando. Ahora le paso un poquito a Karl. Vamos a platicar con Karl. Are you ready, Karl?
Yes.
All right. So, Karl nos va a platicar. Karl tiene más de 5 años en experiencia en robótica y trabaja directamente con Johannes Brauman, que es el desarrollador de KUKA PRC. Tiene un canal de YouTube, uno de los más importantes de tutoriales. Les recomiendo mucho que lo sigan. Ahí tiene tutoriales muy específicos desde cómo montar un CNC, cómo montar un router, cómo instalar MX Automation en tu robot. Entonces, tiene uno de los canales más importantes de YouTube en robótica. Les recomiendo que lo sigan. Y bueno, para ya no retrasarlo más, él va a estar hablando en inglés. Yo voy a estar tratando de traducir en español. Por ahí, si cometo algún error, me dicen y platicamos. Igual si surge alguna pregunta, lo estaremos revisando. Karl, I think you are there.
Hello.
You're live.
Yep. You've got my screen?
Not your screen. I got you.
Oh, okay. Well, hello. Thank you. Oh, I have to do the screen share, don't I?
Yeah.
One moment.
Karl, somebody's asking what's your channel.
If they just look up my name, they should be able to find my channel on YouTube. You've got my screen?
Yes, we got your screen. We'll.
Yep. You good?
Yeah, we're good.
Okay. Hello. Thank you for the lovely introduction, Luigi. From what I understood from the Spanish, you know my Spanish is very little. I'm Karl Singline from Tasmania, but I'm currently living in Linz, Austria, working with Creative Robotics, which operates out of the Grand Garage. My background is architecture. I have a Master's of Architecture, which I gained from the University of Tasmania in 2016.
Okay, so
During my
Karl viene estudió arquitectura en Tasmania, tiene una maestría en arquitectura. Sin embargo, está trabajando desde la Universidad de Linz en investigar algunas aplicaciones de robótica. Está muy resumido, pero bueno, vamos a seguir. Okay, continue, Karl. I'm going to try to translate the most important parts.
would you like me just to keep talking or just pause while you translate?
I think the audio is going to get overlaid. I can translate it as you talk, or
Okay.
we can do it by beats, maybe. What do you think is better?
It's up to you, man. It's your stream.
Okay, let's try to do it by beats so people that speak English can understand the whole thing.
Mhm. So during my Masters of Architecture, which I undertook at the University of Tasmania, I was introduced to both parametric and computational design, as well as the wonderful world of robotics and robotics in architecture in particular. So it was not uncommon to find me during my Masters of Architecture to find me working at the robot, trying to figure out how to get it to do anything, as opposed to, and now through the skills I developed during my Masters of Architecture, I now travel the world introducing people to the wonderful world of robotics, creative robotics, robotics in architecture, and the way that we can use these industrial machines to actually produce unique and exciting things other than just automobiles and electronics.
Okay.
So a big part of what I do in my job is knowledge transfer and introduce just concepts to a lot of architecture students, as well as industrial design and other fields that necessarily wouldn't discover robotics or parametric design at all. So traditionally within architecture and other industries, CAD/CAM looks a lot like this. I'm sure many people, if they're tuning into this webinar, have seen software such as Autodesk's Fusion 360. That is a 3-axis milling that offers a task, and that's all it does. But what if we apply that sort of idea to industrial robots that are designed to do exactly what is shown here? They're built to do one thing a million times and manufacture repetitive tasks, fast and efficient, absolutely. Which means that once they've had their life in a factory, as we saw, then all of a sudden there's an abundance of these machines that maybe have done one repetitive task and worn out a couple of years, but are still good, which leads to a fantastic market of amazingly complex machines that end up on places like eBay for relatively cheap. You look at a high quality 3D printer that does only one material and only 3D prints, something so big. You can find a 6-axis industrial robot on eBay that is still perfectly good and can work with the sort of technology that we've been developing for well under 10,000 euros, and industrial 3D printers go well above. So then the next step was shifting the industrial robots from the manufacturing and fabrication in these large scale factories to the lab space, where we can sort of start to think about doing prototypes for architecture as well as other creative industries at one-to-one. And the flexibility that these industrial robots then introduce is how can they inform design, shift design, and make us think about our design in a higher level of freedom instead of relying on mass-produced fabrication techniques and materials. And a lot of these characteristics are embedded in the robot. So we've got multifunctional machines that can weld, can do 5-axis milling that a 3-axis traditional CNC can't do. The flexibility of the different mounts in the last two images, you can have a camera that you can then calculate the path for to scan 3D objects in a very precise manner, as well as the end effector, which was developed for one of Creative Robotics' exciting projects that we'll get to.
Karl,
And most of all, scalable.
I think we have an interesting question. Do you think it's
Yep.
better to have a robot? Rene Jauregui asked if it's better to have a robot than a traditional CNC or 3D printing machine.
Was the question? Do I think it's better to have a robot instead of 3D printer and an industrial and a CNC?
Yes, so he's asking, is it better to have a robot than having a traditional CNC or 3D printing machine?
I'm complete. It's a fantastic question. The short answer from me is a robot every day of the week. It's where my passion is. But I also believe the right tool for the right job. If you're not doing something that doesn't need 6-axis, then why do you need a robot? But then, a robot is a lot more flexible than a traditional CNC or a 3D printer. So if you want to have more options, a 3D printer does one thing, it 3D prints. A robot does whatever you can imagine to put on the end of the robot. It's a big dumb arm, it's got no fingers, it's got no sense, but you can attach anything to the end of it and program it to do 3D printing, CNC, object manipulation, pick and place, testing materials. If you can imagine it, chances are you can do it with a robot. Whereas with an inkjet printer, 3D printer, a tool that is made for one specific task, that is the only task it's ever going to be good at.
So,
I hope that answers the question.
yeah, I agree. So, in general, you think it's good when you have something very specific, specialized. Maybe it's better to have the right tool, but robots are much more flexible, right? So, it it's
Exactly.
okay. I agree with you. It's a very interesting comment. And somebody's talking about regarding um, welding. He is making working at the Canadian Center for Welding and joining as a postdoctoral fellow.
Mm-hmm.
He's working on a project on a scanner to digitalize. Okay, you probably talk about this a little bit further on, where you have some digitalization, right? So we can keep going, and then
Yes.
at the end we can talk to Daniel a little bit, and maybe he can tell us some more.
Sure.
All right.
So can
Yeah.
continue
Yes.
with it. Another large factor of robotics, which actually comes into the questions we just had, is the scalability of working with such a tool. The code that you output when you're working with a robot works on the left-hand side. We have a small scale angular spot that probably has a payload of about 6 kilograms. On the right-hand side, we have a Titan that can pick up an entire ton. It can pick up a car. And the code, as long as there's no issues with it, can transition from one to the other. So you can prototype digitally with a simulation, and if Kuka PRC outputs or whatever software you're using outputs no errors, you can take that code and just make sure it's set for the right robot, and it will repeat the tasks seamlessly. That's something that not a lot of actual physical, like we're talking about taking the digital into the physical, into the real world. Other processes don't allow so much flexibility when you're going from small scale to large scale, which again introduces, especially in architecture and design industries, rapid prototyping that you see a bit in 3D printing, but 3D printing is limited, whereas in robotics really increases what we can do. Such as, obviously my background is in architecture, so this introduces being able to do doubly curved forms, pairing parametric design, grasshopper and the like, with robot manufacturing. Then all of a sudden we can actually realize these complex geometry shapes to introduce them into the buildings where previously they were either too complex just mathematically, or too complex or too expensive on the fabrication side. But now all of a sudden these what looked pretty standard now designs, which were not too long ago completely out of the realm of budgets, become more standard and more exciting because you're not limited by the materials or the manufacturing processes, such as the 3D printing that was done by Branch in the United States, who used Kuka PRC to generate their forms. It did large one-to-one scale 3D printed structures, which brings us into Kuka PRC. So Kuka PRC is the software that I think Luigi has already mentioned was developed by Johannes Brauman. He's the founder of Creative Robotics, where I now work as a researcher. And the idea was to marry the parametric and computational design with the actual physical robots, both for industry and creative. So here is an industry application where instead of the traditional CNC machine, a robot is mounted on a moving linear axis that can then perform different tasks. And like I mentioned previously, it can have an automatic tool change to do even more tasks than just CNC. You can have a circular saw, you can have a drill bit, you can have a gripper to then remove elements as you need. And we can see some of the outcomes in action here. So this was all developed with KUKA PRC for real-world industrial application. So now the sort of the influence that KUKA PRC in partnership with Association for Robots in Architecture, it has gone from obviously starting in architecture and the adoption of industrial robots for creative means has now crossed over to many industries through automotive, aerospace, construction, fabrication, and even more, all through the power of pairing the parametric with the physical. And on top of that is now the sort of the community that is growing around the adoption of industrial machines in the forum that happens where people are communicating and sharing knowledge as well as just ideas of how we adapt these technologies. And then even communities in other countries that take it upon themselves to translate it into other languages to communicate the knowledge, which is super exciting. Which includes my YouTube channel. I was one of the first people to start sharing the knowledge when I was in university. Nobody knew the capabilities, and I sort of took it on myself to start exploring, and that's how I got to know Johannes and started sharing, and then realized, well, why isn't this easily available on the internet as a 10-20 minute tutorial on how to get an industrial robot to draw? So here we have a look at the benefits of the industrial, back on the question I had earlier about transitioning from traditional to the more flexible robot. It's as simple as looking at an image like this where you see the true 6 axes of a standard industrial robot and the flexibility that you get with the reach, anywhere from 600 all the way up to 3-4 meters. Then a CNC that you can see, you can get lovely 5-axis CNCs for metal work and everything, but they're super expensive. And then if you want to do anything other than 5-axis CNC with those machines, you have to buy another machine. And here is a sample of the code that outputs that demonstrates perfectly. It's very easy to write the KRL, that's the language that a KUKA reads in order to think, but to simulate is where it gets tricky, and errors like this happen on a regular basis, where you can write the code, but it means nothing if you can't simulate it, because these machines weigh a ton, they move incredibly fast, and you want to be able to see what they're going to do before they do it. Existing simulation software as provided by KUKA is quite arduous. You can look at this and see that it's very traditional sort of CAD software where you're basically programming line by line, move here, do this, move there, do that, check for collisions, which is what the invention of KUKA PRC was doing its best to sort of avoid that traditional CAD-CAM workflow, where you've got your geometric design, you shift over into the milling strategy or whatever, 3D printing, traditional, any sort of strategy. You simulate it. If you have errors, you've got to go right back to geometry design. And then finally, once that initial loop is done, you can go to robot milling. Whereas tapping into the power of parametric and computational design, specifically the grasshopper engine within McNeil's Rhinoceros 3D, it becomes a modular sort of system where you can do, your code comes from your design. So you've got the real-time preview as you're shifting your design around. Instead of sending it to the robot and the robot giving you an error, you get the feedback immediately that it's out of reach or there's a collision. So you can see that this isn't the traditional linear method where you're doing errors. You're seeing live, it works. If you make a shift, if you change a parameter, you see immediately the feedback through what the physical machine is actually going to do, creating a much faster and more efficient workflow. So the demonstration of the live data feedback with a full set of analytics for the robot data, informing that an axis is out of reach, meaning that it's going from the range of movement that is safe, and that you can modify your design or your product in real time and get the feedback you need to remain completely efficient. Which brings me into Creative Robotics. Obviously, KUKA PRC is kind of what we work in. Johannes invented KUKA PRC, and Creative Robotics is the founder of. We are a research group out of Linz in Austria. We come under Kunst University, the University of Arts and Design in Linz, where we specialize in applying creativity to the robots that we use. We work almost entirely with KUKA robots, but we work with others as well. We have a lab space in Grand Garage, which is part of the Tobacco Fabric sort of startup facility in Linz, where we have a 300 square meter robotic lab, which is actually at the moment being expanded into some more office space for us. We've just taken on 2 or 3 new researchers in the last 2 months as we continue to grow and research. We have a couple of different KUKA robots. Here you can see one that was suspended, inverted to do some 3D printing for a couple of shows. And this is a makerspace where people can come and work, as well as be introduced to different technologies, not just robotics, but 3D printing and streaming and VR and programming. And a big focus that we concentrate within our lab is skill digitization, the embodying the skills of a human within the robotics. Because when you think of creativity, creativity is a very humanistic approach to the world, where we want to make things more beautiful or add some more function or communicate something in a non-traditional manner. So some of the projects that we've done is actually looking at the skills that is embodied in people that is not easily transferred to a digital state, such as chiseling, where the measurement and the expert craftsman had years and years of experience in perfectly chiseling the stonework. But then when you showed them the data and said, oh, you have it at this angle and you're hitting it harder when you need this, they had no idea, because it was so embodied in the muscle memory and just years of practice and working. And to take that data, and if you apply the information from mapping them, you can get an output from a 6-axis machine that you just cannot get from a human, where we can see that for a human to hold a chisel at an angle and then hit it with a heavy mallet, of course it's going to go to the weakest position and be flat 9 times out of 10. So it's not taking the skill of the person and removing them from the equation. It's applying it and adding it with an industrial robot. A lot like Branch, I mentioned earlier, also do with their 3D printed structures of lattice work forms through KUKA PRC. They actually went on and won a large grant, a large prize for developing a system of 3D printing for the getting people to Mars, and how is it possible to sort of make safe habitation on Mars as a different planet. And then another sort of fantastic group that have been born from the Creative Robotics is Yokai, a couple of young guys who study fashion and communication within Kunst University, who developed their own fashion technology.
Very nice. We got a question, Carl. One of the questions is, how does somebody get in contact with you for a residence? And the other question is, why using KUKA over ABB or FANUC?
I'll take the ABB question at the very end.
Okay.
Can you just remind me? As for getting in contact, either go to my website, contact me on YouTube. There is always opportunities within Creative Robotics. There's opportunities to study at Kunst University, and there's also a knowledge transfer / intern / sort of exchange of knowledge within Grand Garage, which of course we're associated with, that is also a potential for people. So I recommend just hopping on my channel, sending me a message, going to my website. My Instagram is personal as well, but it's all robotics. If I get something 9 times out of 10, I reply, as long as it's not someone being rude and asking me to do parametric design for free.
All right. I think that answers Consuelo's question, and then we'll answer Augusto's questions at the end about the ABB.
Yep, perfect. That's a general broad question. I can cover that though. So Yokai, they've done sort of they looked at the 3D printing technology and applied it to the fashion industry, the fashion world, where instead of traditional sewing of materials together, what if you welded it together with an extruded plastic, and then you can get more 3D forms without the traditional 2D pattern making. So these guys have traveled the world with their technology. Here they are in the Middle East, showcasing their KUKA robot and doing live demonstrations and printings on t-shirts. And here's another little fun one that was born from one of our researchers, Benjamin, developed Printer Drink, where he came up with the idea of taking the sort of extrusion technology and 3D printing shapes within drinks, where he now travels the world and showcases the technology where he developed the material that would float within the liquids, that was also didn't taste terrible and was edible, of course. And this was sort of born through his research that was done within Kunstuni and Creative Robotics, and all, of course, achieved with Kuka PRC. As someone with an architecture background, it's not something that jumps to my mind as immediately great, but when you see the output, it's absolutely lovely, and what a lovely final product. So he's working with Bullet out of America on a regular basis in showcasing 3D printed drinks. As well as a lot of we do is working with industry partners, not only in Austria, but also internationally. And this was one of the big ones that we did with manufacturing and 5-axis milling, where it was the last saddle maker in Austria, and they approached us and asked, we need to get more with the times without losing too much of the traditional skills that were imbued in making a saddle. So it was a big question of prototyping and how we can do it, and then what is the benefit of investing in. You can see that it's quite a large robot, which is a big investment monetarily, but you have to make sure that that investment is returned. And then the question becomes very easy. Well, in order to make a saddle model, it is expensive and very time consuming. But through the adoption of parametric design, all of a sudden you can incorporate custom sizes that you couldn't previously, because you had to have someone hand make the custom. Oh, this person wants it slightly larger than medium. This person wants it slightly smaller than large, where someone then has to develop it. But if there's a parametric model behind the whole process that then can be fed into a robot, all of a sudden they see the potential and they become to be competitive. As well as more, this is a project that was done using the KUKA Iwa, which is a collaborative robot that has a very fine level of data coming through of the pressure. So this was polishing, like professional polishing of car materials and surfaces. And here we see the real benefits of working with high-end robotics, where there's accurate and fine and detailed work. And the robot, above all else, is patient. So it will repeat these patterns perfectly over and over and over, as long as you tell it to do. And these are just skills that, people learn and develop, but then a robot might just do accurately, and instead of getting through it in half an hour, perhaps it can just sit there and do it over a day or longer, and the results are amazing. And then we also like to have a little bit of fun. So this was a project that was sort of given to us regarding music, and it basically started with, can robots play a guitar? Which kind of they can, and kind of they can't. I mean, thankfully, Johannes can't play guitar, I can't play guitar, but we had a student assistant at the time who could play guitar very well and who was eager to sort of give it a try, where we came up that, the fingers a person have are incredibly complicated, and in order to have the strumming as well as the shifting, perhaps we can't get it to play Santana, but we can get it to play a melody. So that was the initial prototyping of the project, where we developed an entire plugin where you could put in different music, which was automatically generated through Grasshopper, to create the robot movements that needed. So it was the shape, the size and color of the shape dictated what the robot would do. It was a complete working functional plugin to generate from parametric design into robotic movement that resulted in actual music chords being played. And then when it came time to actually present, what's better than 2 robots? Of course, 3. So we put them on a 3rd robot for the final act.
Carl, we're unable to hear your videos, so maybe you can share later where they can actually see these the guitar playing and the sound and everything.
Oh, you're not getting the video?
We're getting the video, but not the sound.
Oh, okay, yeah, sure. Just remind me. As well as an installation that we did for McLaren pop-up store in Zurich, Switzerland in 2018, where this wasn't, you can look at it and it's a robot that is clearly just polishing, dusting the McLaren supercar, where it's more just an expression of technology. The project itself is pretty straightforward, just the tool pathing, but pairing it with the technology to sort of showcase, yes, this is capable of a lot more. And each year, Creative Robotics is invited to participate in Ars Electronica Festival that happens yearly in Linz, which is one of the biggest sort of cultural electronic festivals, where it's about creativity and artistic expression with technologies, not just robotics, but of course a lot of what we do is robotics. And this is a project that was done by one of our researchers and a colleague of mine, Emmanuel, of robots doing nothing, where the data that is being sent to the robot is actually driven by external data and some AI, and the robot just responds to that, and it's the geometry that's generated through the strings that are attached as it just rotates and operates within the space. Which became a bit of an installation. And then we come into the big time projects of each year. There we're asked to sort of demonstrate or participate for something. Sometimes it's the Gala, sometimes it's something else within Ars Electronica. And in 2018, it was a dance performance with a full orchestra, with the fantastic Silka performing with the robot as another dancer, where you probably shouldn't be jumping and dancing around a live robot, but it's artistic expression, I think, and worthy. So we had a couple robots during this performance in 2018. Which leads into our 2019. So when you have one or two robots and they ask, the only sort of brief is bigger and better. So what's bigger and better than one or two robots? 5 robots. So last year we had a 4-tech with 4 Aguluses all attached to the end as the end effector, where Silka once again was the performer who was motion tracked in a studio. Her dance, her performance was completely recorded, which we then could translate into robotic movement across the 4 robots using Kuka PRC, of course. And then during the performance, she actually danced with herself being replicated by the robot. So she was dancing with the recording of herself. I don't have the video here for some reason, but that's on my YouTube channel. There's a fantastic video of just a bit of the process and getting the robots to talk to one another. It was a big, stressful couple of weeks for Creative Robotics, but thankfully it worked for a couple of performances and it was a part of the gala. And then finally, we have Robots in Architecture has a conference every 2 years. Obviously, 2020, unfortunately, has not happened, but since 2012, every 2 years there is a conference that I highly recommend people look into if it's available or practical to attend, where workshops happen, people communicate, deliver papers. And this is another video without any audio that you can hear, but so it's a chance for people to come together, develop new ideas, and learn a lot more about the creative robotics scene. I recommend if you have the opportunity to attend. I mean, it's a fast track way of getting some skills, and some of the top roboticists in the world are always in attendance. You might even have a chance to meet me sometime in real life.
Any chance it's gonna happen in Mexico soon, Carl?
Luigi, that's on you, mate. You have to convince us.
We'll bring it to Latin America for sure, one day.
Yeah, we've had United States, but no Mexico, and I know Johannes is not against the idea.
So also once all the COVID is done, we are planning to have a workshop with you, Carl, in Mexico, right, where you can show us all these skills and help us get our projects done with robots. Probably focus at digital manufacturing. We probably are looking for next year, right, Carl?
Yeah, absolutely.
All right.
It was January when I was last in Mexico, and we taught a lot. And it would be great to get back there and teach a new group.
Great. So, or is your presentation? Do you have something to add to your presentation, Carl, before we go to the questions?
No, I think that's about me sort of done with the work that we do, and we've had a bit of an introduction to KUKA PRC as well as how we work and the work structure. So let's have a few questions, shall we? Can I stop staring at my PowerPoint or
Yeah. We can.
stop staring at my
All right.
screen?
So we'll go back. So let's do some questions and answers. Remember, we have a little delay. We'll we have a small delay, but right now it's a good chance. Meanwhile, while the people ask their questions, uh, maybe we can answer the ABB and Fanuc versus KUKA robot. Why KUKA PRC is KUKA PRC?
Why KUKA? I get
Yeah.
this question all the time. And it's not a bad question. It makes perfect sense. Like, is there something about KUKA that is better, or, you know, like when you're working in technology, you want to think you have something, or working with the best, of course. But I studied architecture and my school had a KUKA, and they had the license for Kuka PRC, which only operates in the KUKA environment. Every robot manufacturer has their own language, like um, like a lot of they're not open source unless it's one of those little open source bots. But ABB has Rapid, KUKA has KRL, and there are plugins for Grasshopper that do KUKA, ABB, Fanuc, of course. But I was introduced to KUKA PRC, and through my sharing and my work with YouTube and knowledge transfer, I have a good relationship with both Robots in Architecture, Creative Robotics, Johannes. But students looking to get into robotics, I say you don't need a robot to start, you just need to start simulating, and then whatever you can get your hands on. If your university has a robot of a certain manufacturer, then it's a robot. There's nothing inherently. I like KUKA. KUKA work really well for me. Their operating system, I was recently introduced to another brand of industrial robots, and their user interface was like time traveling back to 1995. And I'm very comfortable with KUKA. I'd rather be a master of something than a jack of all trades. But at the end of the day, they all work on inverse kinematics. The idea of working with an industrial robot translates to any industrial robot, and it's not so important to know everything about one language as it is to know the logic. It's like programming anything. You have to understand the logic, and you can Google the syntax from Python to C#, C++, from KRL to Rapid. They all have if, else, if this, do that statements. If you can get a robot, I recommend whatever you can afford, whatever's convenient, whatever your school has. Grasshopper has a plugin.
Actually, somebody's asking about that. They're asking between all these add-ons for Grasshopper working with robotics, uh, which one do you prefer, KUKA PRC or HAL? Well, obviously KUKA PRC. You work with KUKA PRC. All your tutorials are about KUKA PRC. But what do you think makes KUKA PRC stand out from other robot control add-ons inside Grasshopper?
Look, KUKA PRC, that's an unfair question, Luigi.
Why this?
If KUKA PRC doesn't have something I want, I look over my desk and say to Johannes, can you please do this for me?
That's true. So you work.
It's the only plugin that I have immediate access to the creator and be like, hey,
All
this
right.
isn't doing what we wanted to do.
That's a big plus, I guess. That makes a whole difference.
Yes, I think KUKA PRC is fantastic for learning as well. And this is me being completely genuine. In all my years in robotics, I haven't met someone as patient and so willing to transfer the knowledge. We showed the forum during the presentation where Johannes will probably answer within a couple of days if you have a good question or a question. I think it's a fantastic platform, but at the same time, there's robots, which I know you've had a bit of a play with, which is open source on Food for Rhino, which includes a lot more robots. It does what KUKA PRC does, but because it's open source and it allows for ABB and UR, and for me, is it as refined as it could be if it focused on one? No, but that's not what they're going for. They want it to be as open and inclusive. Whereas for better or worse, KUKA PRC is KUKA, and it works. And that's
So here,
functional.
I understand one of the biggest factors of using Kuka PRC is that the developer is very accessible. It's someone very open that's willing to help people. So
Yes.
we had a chance to talk to Johannes. He was in the workshop. We had a chance to talk to him directly. It was very nice. So like Carl says, I think it's if you like Kuka PRC, if you think there's something nice, Johannes is always willing to hear. The other question. Do you think that KUKA being acquired by China will influence negatively or positive KUKA PRC, Carl? I mean, it's this is more operative for KUKA, but do you think it can change
Will
anything?
it affect KUKA PRC, the
Yeah,
plugin? No, absolutely not.
the way we work. So the way you work, no, you don't think that really matters in
No,
work.
absolutely. I've been privy to some conversations that aren't like private or anything. It's just boring to talk about. But KUKA PRC is a fantastic tool that is for their robots. Why would they not want that?
So here's a really interesting question from Daniel. Is there a very specific workflow that you have set when designing a new application? I mean, for choosing file format files, processing the files, for example, in the application where the dance was made, recorded. So I think yeah, like if there's a specific workflow. We talked about this once, I remember, when I was asking you about the same thing for digital manufacturing, and you said, well, the good thing about KUKA PRC is that it allows you to make your own application from the bones out, right? Very personalized, right?
The way That's a fantastic question, which is not doesn't have a simple answer. Yes, is the really short answer to answer. Is there a workflow? Yes, but KUKA PRC with Grasshopper is not necessarily a tool in my mind. KUKA PRC is a platform, and you build on top of that platform. Literally in this previous week, this week, we needed to apply some machine learning that doesn't exist in Grasshopper. And the goal was to then develop the new workflow that fed seamlessly into KUKA PRC, because we're using it as a platform. And that platform is built on Grasshopper, which is, if you know C#, you know a bit of Python. Well, really, I don't think you need C++ for Grasshopper at all. I recommend people go with C# first and then Python second. And you can then build it as a platform. Oh, I need this. I know how KUKA PRC works and I know what the data I need, but then I use it as the platform to get to the robot. So you have that workflow. Oh, if I need to do a quick analysis of data coming from a file or coming from Grasshopper itself, it's a quick Python script to say, oh, do this, keep track of that. If it's this, do that. If it's something else, do something else, or do nothing. And then if I need to do something a bit more serious where I need a custom component to then, generate data, which is what we did with machine learning this week with ML.NET. From what I can find, nobody's done it before, is Johannes developed the component, we fed in the data we generated, and then it fed into KUKA PRC. It's not so much a workflow as it is just a platform like any other platform it is that then you build upon.
You can build
I
your
hope
own.
that answers your question.
Yeah, I understand that what you're trying to say is that you can build your own workflow on KUKA PRC. So if you have a specific workflow, you can pretty much automatize certain things to create your own workflow and kind of streamline.
Well, there's no singular workflow because what we do is so different every time.
Yeah.
Like, if I'm doing something two-dimensional with a single-axis tool like drawing, it's just
Yeah, but
that's just a
for
yeah.
that application, you can streamline the process of the robot drawing, right? You make kind of that.
Yes.
Yeah. So, okay, I think I can answer these questions. Are we in San Luis Potosí, Mexico? Well, yeah, there's offices of KUKA in San Luis Potosí, I think. I think they're in San Luis. Pretty sure they are. MakerMex, it's in León, Guanajuato. We are actually integrating robots uh, on digital manufacturing. So if you want to 3D print, you want to use CNC milling or these kind of applications, we can help you with that, and we work very close with KUKA Mexico. They're in San Luis Potosí, and Karl is a big support of all our projects. When something gets too difficult, he's always willing to help, and you can contact us for more information on that. Um, yes, Daniel's happy with the answer, and Augusto, it's in Colombia. Okay, so yeah, KUKA robots, I think they're being manufactured in China, I think. All right. Um, I don't see any more questions, Karl. Anything else you wanna?
What have I got? How do you evaluate which information and in which formats is better?
Where is this question?
That's by Daniel as well. That's a good question.
Okay.
That it's a really good question. That comes from experience, um, and experience and just a little bit of research. Like I said, if you're just processing data where you don't need an application, you don't need a true, run function type thing like C#, where you have input, said you want to run a script. It's Python. And then there's also external sources where you just want to run something to a text file and output points. It just comes with practice. And even if, for me, like at the end of the day, what's important to me is the realization of digitization within the physical. Like I focus on getting the data on the robot. If Python, I know Python better than C#. If it's quicker for me, but then the script takes a bit longer to run, I don't worry about it. I don't think about that. I just, as long as the result is there and on the robot, and if the project continues, then maybe I'll look at, is there any efficiencies we can save? But at some point, you've just got to do the project. You've got an idea, get the robot to do it. And then in other situations, that's more, the logic, the programming. And it's just whatever gets the job done. Like, I don't want to spend my time reinventing the wheel. If I need vectors, I go to Illustrator or I use Rhino. If I just need a point, I just generate a point. I don't need to code that. It's not adding anything new or anything creative or architectural. That sort of the workflow and that sort of intuitive, I need to do this, is just practice. And you'll find, I can't easily achieve this in Grasshopper. But then you look at, what else is out there, or maybe I need to use the GH Python component or, a quick, and then you go on Stack Overflow and someone did it 20 years ago and you copy and paste.
So we got another question from Majo Chavez, and Daniel is also asking something else, but let's go with Majo first. She,
Yep.
she asked, what's a good way to get started? I think, like, the knowledge you would recommend for a student to start in robotics. What's a good place to start? I think I can answer that. There's a very good YouTube channel. I don't know if we'll post it. It's Karl's channel. He makes some really great tutorials from setting up the basics of the robot to more complex applications. You can find a lot of information there. Um, I think YouTube is and your channel is a good start point. Don't you agree, Karl?
Yeah. It's just my name. Um, Rhino offers trial for 90 days. There is a free version of Kuka PRC. Marry that with just doing a couple of my tutorials. You'll quickly discover if it's something that you're interested in and you really want to pursue. After 90 days is a long trial, and do one of my tutorials every second day, you'll quickly discover whether it's something that really interests you or not. And I recommend everybody. For me, I think it's a very important skill moving forward, especially in architecture, construction, any design, where things become more digital, and the benefits you get from being more creative by manipulating and leveraging these tools like a programming language to output better or more informed results. That doesn't mean I don't still sketch. Like if I have a complicated problem that I can't wrap my head around, the first thing I do is still grab a piece of paper and draw it out and be like, well, what am I missing? Like, it's not all digital, but I recommend downloading Rhino, grab KUKA PRC, the free version, which is fantastic, and robots as well for ABB or other, the UR model robots are really cheap. And then you've got no excuse not for going into it. And then if you like it, find a university that has a robot, see what courses or shit. Nobody was going to teach me. I was studying architecture and I kind of just forced myself to use a robot.
That's great advice. Just get started. I like that. Just you have an excuse. That's a great way to see it, Carl. We have a question. Will you ever share a tutorial on a milling program based on a design? I think you probably already have something like that.
My milling tutorial is very just generate random curves and but that's like, for my personal knowledge transfer on YouTube, I get questions about other very specific robot use cases, and some of those use cases are dangerous, I guess is the word. Like if it's like RSI, which is a way of interfacing with the robot, if it's not done well, can cause damage. Like these are industrial robots that move at 2 meters a second, swinging 100 kilograms of weight on the end of them, let alone the weight of the robot. So that there are areas that I don't get into just for safety, where it's now that I'm starting to do more MX automation, I'm aware of MX automation sending data to the robot. You've got to rely on the robot to choose that it's safe, and that's KUKA's platform, so I'm a bit more comfortable. When it comes to design specific, it can't be so specific that only a handful of people find it helpful. I did an introduction, like here is how you do 5-axis milling. If you tinker with that code, you should be able to do 5-axis milling for any shape. And then if you, like, I get questions regularly, how would I do this? And I just say, well, you've got this video and you've got this video that tells you how to do it. Just put the code together. And, I can't fix every problem.
And
I
really,
don't,
Kuka PRC also has this. You can import Fusion 360 cam, right? So you can really
Yes,
easily
that is
import.
that's pretty traditional milling. Like that's almost 3 axis.
Yeah.
Yeah.
Um, okay, Daniel. Yes, of course we can collaborate. Let us know. Right now, sure it's easier with the distance. Everyone's getting used to video conferencing and all. So let us know if we can help you anyhow. Um, Let me see. So that's really no point. Okay. So I think you can learn some robotics without the robot on Kuka PRC, because it allows you to simulate. So you can learn some concepts first, actually, before investing on the robot. Maybe you can try on the simulator in Kuka PRC. I think that's a good way to get started. Find out if you get comfortable and confident with it, and then bring it to the robot. I mean, usually that's also a good advice to start first in the simulator, right, Carl, before going to the actual physical robot.
Yeah, there's no reason not to give it a try. Like if you discover you just do not like grasshopper or you do not like programming, then it's a good way to just have a gate. But then there is nothing better than seeing the robot move. I had been watching it for 5 years, and I still don't get bored of introducing people to robots and just watching them do things. It's like, at the end of the day, it's like, how do I become an architect or a doctor? Or there is no, at the scale of what I've demonstrated today, there is no easy, unless you have access to a lot of money, to buy your own robot and just be like, well, I am interested and I want my bot. But like I demonstrated, there are second-hand robots on the market that are affordable. And if you can afford it, I would never say don't do it. Like, if you're interested and you have the money, go for it, of course. And then, if you have a question, get on the forum, become a member of the community. You're not going to go unanswered. You're not going to be stuck forever. I see a question I would really like to get to, Luigi, from I think a friend of ours.
I see Sujay asking some questions. Hello, Sujay. Nice to see you. Nice to read you here.
Good to see you, Sujay. It's been a while. It's a fantastic question, I think, given the current COVID lockdown, robots and the possibility of remote fabrication is being discussed actively. What is the best way to develop this workflow? Yeah, you come in with the big questions, Sujay. It depends on the output. Like, we're talking, the goal is online programming from a distance, which means that we can have enough data that we can safely operate a robot that we're not in front of and give it life, because we've been doing offline programming for years. This is what we're attempting to move away from, where a car manufacturer has 50, 100 robots manufacturing a couple hundred cars a day, going through the process, and there's nobody there unless something happens or an error is fed. That's the whole point of automation. It's the create, like, that was achieved. Like I said, that was achieved years ago. That's what the robots are built for. It's the introduction of human input from a distance that can allow the robot. We're doing some, slowly developing some feedback through HoloLens, where we've put KUKA PRC within the Unity engine and then paired with the HoloLens, which has a fantastic AR environment where perhaps you can simulate the robot through the HoloLens and then give it data to move. And then you can have another stream from a webcam or some source where you can see the actual robot take your commands. Again, it's use case. So perhaps I think it's, for that, it's just a matter of making sure there's not enough latency, that what you're seeing is alive enough that in 2 seconds the robot doesn't go through the wall. But I'm very curious on how you can monetize that. Like I said, they've been doing it without anybody there for years. It's got to be a task that needs some sort of human input, and then thank you, Sujay. I don't know. That's the last question you get.
Okay, and I think that answers all the questions. So thank you, Carl. Thank you very much for this beautiful morning, beautiful afternoon over there. Now,
Oh, well, thank you. Thank you very much for the invitation, Luigi. Always a pleasure. And I got to say, the questions were really, really good.
thanks, Carl. And so, a good way to reach you, your YouTube channel. I'll put the link right now.
Yep. And the Creative Robotics website is going to be refreshed in the very close future, which will make it a bit easier to reach us as a team. We're growing, so I make sure that all our jobs are posted on my YouTube, Facebook, whatever you call that, and my Facebook, and the Robots in Architecture forum. keep an eye on if you're interested, keep an eye on the university job posting listing as well as Kunst University is a fantastic university to study, I think, but I enjoy working there.
Thanks, Carl. Thanks, Carl. And everyone, a todos, gracias por haberse conectado. Thank you, everyone, for joining us today. Like we were saying, como estamos diciendo, un buen lugar para empezar es buscar el canal de Carl de YouTube. Aquí está la liga, youtube.com/Carl Singline. Pueden también visitar el sitio web de robotsinarchitecture.org, donde pueden descargar KUKA PRC para probarlo en su versión de Rhino. Tienen una versión de 90 días que pueden descargar de prueba. Y si están interesados en integrar aplicaciones de manufactura digital en su empresa, en su escuela, en sus proyectos, en su universidad, investigación, pueden enviarnos un correo a info@makermex, en donde estamos en toda la disposición en los países de habla hispana, Estados Unidos, en América, de apoyarlos y de buscar la manera de ayudarlos a hacer esta integración. Thank you, everyone. Gracias a todos. Excelente día. Carl, thank you very much. Now we go get some beers, I guess. All right. I'll finalize the transmission. Bye.
Ciao. Bye.